Looks clear.
Hello.
Good shooting! Yeah, way to go!
Hello.
Oh no!
The project aims to create an enjoyable laser tag experience where players can play against the turret as well as against each other. The system consists of the following parts: the turret, which is able to autonomously track and shoot players, the guns, which are used by the players to shoot the turret as well as other players, and the remote, which is used to set the game settings for the guns.
Pew, pew.
The turret is able to track an object by means of OpenCV color and face recognition, combined with controlling the motor. When a gun or a face is detected, the laptop will send commands to the Arduino and the ESP32 to pan and tilt the camera accordingly as to track the recognized target. The software running on the laptop can be described by means of the following flowchart. Note that any I/O action is passed through the appropriate microcontroller. As one can see, there are three processes going on at the same time, namely the IR motion scanning for the motion detection, the RGB LED and human detection, and the hit detection. In practice, these are implemented by means of having a separate process for the color detection and human detection, and having a thread that listens for input to the laptop, as well as having a separate thread which implements processing the motion detection input. The reason why the human and RGB LED detection is put in a separate process is because separate processes can be put on separate processor cores, which is ideal for processing heavy tasks such as the human and RGB LED detection, as it allows for true concurrency, improving the responsiveness of the system. Once the turret has locked onto a target, it will start shooting at it. When the turret is shot, it will point down for a short while and come back online after a few seconds. The turret also has motion sensors to be able to detect a target when no target is in direct sight by the camera module. Additionally, the turret plays appropriate sound effects based on its current state. The turret itself is made from wood and 3D printed plastic components. 3D printing was used as it is accurate, fast, and relatively cheap. 3 separate microcontrollers are used to control the pan, tilt, and motion detection, as well as shooting.
The core of the guns consists of an ESP32 with an 18650 battery holder for mobility. The gun has buttons for shooting and reloading, and a vibration motor for physical feedback. The front of the gun consists of a laser as well as an infrared transmitter and receiver. The laser is used for visual feedback and aiming, while the IR transmitter will emit a PWM pulse on firing, following the NEC protocol to transmit an address and a command. This data is used by the opponent's IR receiver to measure the identity and team of the shooter with the purpose of scorekeeping. Infrared was chosen as it is blocked by objects, can be directional using directional LEDs with an output radius of 5 degrees, and is not visible to humans, which are all properties that are required for the use case. Lastly, each gun contains an RGB LED with a diffusion box to identify to which team a player belongs. This color box is used by the turret to aim at the player. The guns are accompanied by a remote, which consists of an ESP8266, an IR transmitter, and an OLED display and a rotary encoder. Its purpose is to set the gun's various settings, such as its team, ammo, number of lives, and the brightness of the RGB LED. Guns belonging to the same team cannot shoot each other. An exception is Team 0, which is the default, allowing for free-for-all mode. While developing the project, first all parts were separately developed and tested. For integrating these parts, communication between different components was vital. The laptop that analyzes video feed needs to communicate with 3 microcontrollers that control the turret. This communication is achieved with messages over serial interfaces. Each message is only 3 bytes long. Furthermore, the microcontroller controlling the shooting of the turret and motion detection sends messages back to indicate if the turret is shot or where motion is detected. During the project, several problems were encountered. One of which was that the motor driver was not able to handle the amount of current going through it. This resulted in temperature issues, which resulted in the pen motor showing unexpected behavior, such as skipping steps. This was ultimately solved by using a different motor driver. A second problem was that for each room in which the system is used, the lighting is different and hence manual recalibration of the color detection is required, which takes quite some time. Another difficulty that we face is that the project that was devised was quite extensive. Hence, less time could be spent on creating models for the system, as the implementation took up most of the available time. All in all, we are very content with the performance and the state of our final system.
Pew! Pew!
Finally, we want to give a quick overview of how the different tracks of the module were used in our project. First, knowledge of both track 3A and 3B were used in the control for the pen and tilt motors. Especially the pen motor required a more complicated controller, since an acceleration curve needed to be implemented to ensure it would not be skipping steps. Secondly, track 4 was used in 2 ways. First, the knowledge about communication networks was used to implement the IR communication. And secondly, the knowledge about machine learning was used to find a suitable model for facial recognition. The knowledge of track 5 was used in the image recognition and controller design, as implementation is very similar to how the Go-by-Go controller was designed in that project.
Pew! 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 Pew!